students. Today let's go through the recap of the chapter 8 motion. We've already been taught this. Let's just have a recap of it. So basic motion. Your chapter name is motion. What does motion mean? Motion is change in position of an object with respect to time. This is very important. What is change in position? You can just call it movement. You are moving somewhere. You're changing your position from one place to another place. That is just a movement. Now what is motion exactly in physics? So motion is change in position of any object with respect to time. This with respect to time makes many difference in this definition. So defining motion with respect to time is very important. Now when you say it is a motion, you will have to define it with respect to a reference point. Reference point can be anything. For our example, let me take Earth as a reference point. So we all know that Earth revolves. So if Earth is revolving, we should revolve. Generally that's a basic sense. Assume you are sitting on a chair. Do you really revolve? No. If Earth is taken as a reference point, you really don't revolve. Only Earth is revolving. You are still constant. You are not moving. So with respect to Earth as a reference point, you are not moving. You are a constant body. So this is about reference point and motion. This is very important. With respect to time and with respect to reference point, you define motion. Next is something called rectilinear motion. Maybe you all know about a word called linear. What does linear means? Straight. Linear means straight. So rectilinear motion is nothing but motion along the straight line. Assume you are moving in a highway. Highway is a straight line. So when you are moving on a highway or any straight path, that movement or motion is called as rectilinear motion. So rectilinear motion is a motion along straight line. Easy. Next, second one is scalar and vector quantities. Very important. So what's a quantity? What is a physical quantity basically? So physical quantity is something which can be measured in numbers. Like your time, 2 minutes, 3 minutes. Like your mass, it's 5 kg, it's 8 kg. So any quantity which can be measured using numbers is called a physical quantity. Some examples of physical quantities are your mass. Mass is nothing but your weight. You measure, this is 5 kg, this is 10 kg. So that is again defined using numbers. And volume, volume, liters. You can measure your water, juice or whatever in liters, 5 liters, 10 liters, etc. And then is length, length, 5 meter, 10 meter, etc. And time, we all know, 10 minutes, 3 minutes, whatever. So all this which can be measured using numbers are called physical quantity. These are some examples. So among these physical quantity, we again have two different type of quantities. One is scalar and another one is vector. Now what does scalar means? It is a physical quantity which is specified or defined only in magnitude. So if you have difficulty in understanding magnitude, you can also define it using size. Magnitude is nothing but size. So scalar quantities are only specified or measured using size. So you might be thinking, what all the quantities which you measure using size or magnitude? Example can be length, how long it is, how short it is. So length is a scalar, and speed, how speed the car is going or the vehicle is going, and weight, mass. So length, speed, weight, mass are physical scalar quantities. You only define it using size. See, if the length is 3 meter, it is 3 meter throughout. Even if you hold it in this direction or this direction, it is 3 meter. It do not change, correct? Same, speed and weight. Whichever direction you are moving in, your speed remains the same. So scalar quantity are defined only in magnitude, remember. Now coming to vector quantities, what is the difference? Vector quantities are specified using both magnitude and direction. This is very important. They are defined with respect to direction. Example is displacement. Displacement is nothing but movement of an object from one place to another place. Now when you are displacing something, you will tell move it to right, move it to left. So what does right, left mean? Direction. So with respect to magnitude, you are also defining direction. So hence displacement is a vector. Again force, if you are applying force to your right side, force is only to your right side. It cannot be throughout the other sides also. So vector quantity is defined in direction, right, left, up, down, whatever it is. So I hope you got to know the difference between scalar and vector. Scalar have only magnitude, no direction. Vector has both magnitude and direction. Examples you have here. Okay, so after scalar and vector quantities, we have distance and displacement. So basically, what is the difference between distance and displacement according to you? Just think, distance and displacement. What is it? Distance is how far you are from something. Displacement is movement of an object. So this is the basic difference. So let's go in depth. So what is distance? It is a total path length traveled by a body. Total path length. Say you are moving from your school to your home. So what is the total distance? Total path covered. This total path is called your distance. Distance from your home to school. So like that. So distance. What do you think distance is? Is it a scalar quantity and vector quantity? What does scalar quantity have? Only magnitude. What does vector quantity have? Both magnitude and direction. So distance. You got to know the difference of definition of distance. So now what is the quantity distance? Is it scalar or vector? Think. Yes, it is scalar. Why is it scalar? Because there is no particular direction. Either you move from your school to home or from your home to school. It is same. You are traveling the same distance. It is certain kilometer itself. No matter what it is, the direction do not change. The distance remains same. So hence this is a scalar quantity. You are measuring this only with respect to kilometers or meter. So it is scalar. Next, coming to displacement. What is displacement? It is the shortest distance measured from initial position to final position. Displacement can be defined as the shortest distance measured from initial position to final position. So assume this is your initial position. Say this is your home. So what is your final position? Your school. So you are starting from your home to reach your school. So the shortest distance measured from your home to your school, the shortest distance is known as displacement. So are you clear about the definition? So this is displacement. Now is displacement a scalar or a vector quantity? It is a vector quantity because you are measuring the distance, direction from initial position to final position. So this is the difference between distance and displacement. If asked in exam, first define the definition, then categorize them according to scalar and vector quantity. So we are good to go. Next it is uniform and non-uniform motion. Basically, what do you mean by uniform? Uniform means same. So why do you wear uniform to school? Because to show equality. Uniform means same or equal. Similarly in physics, what is uniform motion? You know what is motion. First definition was about motion. Now what is uniform motion? If an object covers equal distance in equal interval of time, it is called uniform. Easy. Uniform means equality. So equal distance in equal interval of time. So you are traveling in an equal distance in equal times. You are not changing your speed. Once fast, once slow. No, you are not changing. So this means that in uniform motion, your speed is always constant. Throughout your journey, your speed is constant. That is why it is called uniform, equal, constant motion. So clear? Next it is non-uniform motion. Obviously, opposite of this. If an object travels different distance in different time frame. Assume for 3 km you go in 50 km per hour speed. Again for further 3 km you slow down it to 20 km per hour. Again for the next 3 km you speed it up to 80 km. So you are changing your speed according to your distance and time. So this is non-uniform motion. Your motion is not uniform. They are not equal. Sometimes it is speed, sometimes it is slow. So hence it is called non-uniform. Example, so here in the previous uniform motion the speed was constant because you were moving with a constant speed. Here no, you are not moving with a constant speed. So you will have to calculate your average speed here. Please remember in non-uniform motion you always calculate average speed. What do you mean by average? Cumulative of all the values you have travelled. So average speed is total distance. Whatever distance you travel, so total distance divided by total time. It's okay even if you travel non-uniform distances or unequal distances. Just add all the distance, total distance you traveled and divide it by the total time taken by an object to cover that particular distance. So this gives you average speed. Now let us look at the problems on uniform and non-uniform motion. So I hope you are clear about uniform and non-uniform motion. Quick recap. Uniform, the speed is constant. You don't have to find anything. But in non-uniform, you'll have to find the speed using average speed formula, which you've been gone through already. Now there's a first question. What is the average speed? They have given you a picture. So this is a car. This is city A and city B. So the car is traveling from city A to city B. Now let us see the distance speed, like how it is traveled. Now it starts at 9 a.m. and it is reaching the city B at 11 a.m. So that will take it later. Now first distance. First it is going at 30 kilometer distance at 30 kilometer per hour. So first 30 kilometer, it is at what speed is it going? 30 kilometer per hour. Next, it is stuck in traffic for 1/4 half an hour. So we don't know what time is it taking. So 1/4 of that time it is stuck in traffic. So what happens when you are stuck in traffic? Do you think will you travel? No, your distance is 0 because you are at a constant position. You are not moving. So that the distance is 0 here. Now after traffic, it traveled 15 more kilometer with the speed of 20 kilometer per hour. So first it was moving with 30 kilometer per hour. Now it is reduced to 20 kilometer per hour. So we got to know this is a non-uniform motion. So we know the average speed formula for non-uniform motion. So what is the average speed formula for non-uniform motion? Please recollect. So average speed, as I told you before, average speed is total distance. So remember, total distance by total time. Correct? Now what is the total distance travelled? So first 30 kilometer, next 0, next 15. So from city A to city B, what are all the distance covered? 30 plus 15. You can take 0 also, which makes no sense. You can take if you have any confusion. So distance is 30 kilometer, total distance plus 0 kilometer plus 15 kilometer. So this is my distance. So total time. Before finding total time, how would you find time? So we all know that speed is equals to distance by time. So how would you write time here? Okay, so how would you find time now? What is time now? So your time becomes distance by speed, correct? Time formula becomes distance by speed. Now for first time, what is the distance? 30. So divided by what is that particular speed? 30 kilometer per hour. Plus you are taking total distance, total time. Next for second, it is 0 by 1 by 4. So which is 1 by 4 hour plus 15 by 20. Now let me add it. 30 plus 15. 45 kilometer divided by, so 30 becomes 1, 30 by 30, 1 plus 1 by 4 plus, so what is 15 by 5? 15 by 20, 3 5s are 15, sorry 5 3s are 15, 5 4s are 20, which is 3 by 4. So if you solve this, you will get 45 kilometer divided by 1 plus 1 by 4 plus 3 by 4. How are you solving it? So what is my LCM? 4. So my answer becomes 4 plus 1 plus 3. 8 by 4, which is 4 1s are 4 2s are 2. So 45 by 2. So how is it given? Kilometer per hour. So this is 2 hour. So what is 45 by 2? 2 2s are 2 2s are. So it is 22.5. So what is the unit of speed? As I told you, kilometer per hour. You can just assume it from here only. Kilometer remains here only. So hour comes up, it will become kilometer per hour. So what is your average speed? 22.5 kilometer per hour. Are we clear? So average speed is 22.5 kilometer per hour. Okay. Please note it down. Okay, so let me teach you the second problem. So John travelled for 3 hours at the rate of 50 miles per hour and 2 hours at rate of 60 miles per hour. So what is his average speed for the whole journey? So miles per hour is nothing but speed. Your rate, don't get confused if you see rate in your question. That doesn't mean it's a new problem. It is nothing but speed. So rate is nothing but speed. Now, what is my average speed formula? First write down the formula. Average speed is equals to total distance by total time. Correct? So, but do we have total distance given here? No, there is no kilometer or total distance given. But still we can find distance using the given quantities. Before that, what is simple formula of speed? Distance by time. Now, what does distance become? Distance becomes speed into time. Correct? So, your distance will be speed into time. Now, in place of distance, I will use this. So, what is my first speed given? 50 miles per hour. And what is its time taken? 3 hours. So, for 3 hours, I am taking 50 miles per hour. So, I can multiply my speed and time for first half. So, which is 3 into 50. Correct? Since it is total distance, you will have to add it. Just like your previous problem. Now, for second, what is my time? 2 hours. What is my speed? 60. So, multiply 2 into 60. Now, time. What is the total time? Can you find? We couldn't find the total distance, but can we find the total time given? Yes. So, it is 3 hours plus 5 hours. So, total is 3 plus 2. Sorry, 3 plus 2. So, multiply is 5 3s are 15. 150 plus 6 2s are 12. 120 divided by 3 plus 2 is 5. So, my answer becomes 270 by 5. If you solve it, 54. What is my unit? Please don't forget to write your units. What am I finding? Average speed. What is the unit of average speed? Kilometer per hour. Or, but here we can write it kilometer per hour if given in question. But what is given in my question? It's miles per hour. It's not kilometers per hour. It is miles per hour. So, use the same unit. So, 54 miles per hour. So, 54 miles per hour is my average speed. So, total the average speed travelled by John is 54 miles per hour. Please copy down. Okay. The next topic is velocity. So, you got to know the definition of speed. What is speed? It measures how fast an object is moving. Similarly, what is velocity? Velocity measures how fast an object is moving, but in a particular direction. Speed just measured how fast an object was moving, but velocity along with speed, it measures in which direction, particular direction an object is moving. So this is important. What is the slight difference that makes velocity and speed different is that velocity measures the speed in particular direction. Okay, so since we got to know that it is in particular direction, easily we can conclude that it is a vector quantity. So I hope you know what is a vector quantity. The quantity which has both magnitude and direction. Since velocity has magnitude and direction both, it is a vector quantity. Now coming to formula. So formula for velocity is displacement by time taken. So please see carefully the velocity formula is distance by time taken. So not distance by time taken, it is displacement by time taken. Be very careful. Now what is the SI unit? It is meter per second. Displacement by time, so unit is meter per second. So just like speed, we have two types of velocity, uniform velocity and non-uniform velocity. I hope you are clear with the definition of uniform and non-uniform. Uniform means same. Similarly, in velocity, if the magnitude and direction of an object both are same, it is a uniform velocity. So how are they both same? So assume a ball is rolled on a straight floor. So in first second, it is traveling so many distance. In the next second, same distance. In the next second, same distance. In the next second, same distance. So the ball is covering same distance in same time interval. So the magnitude and direction both are same. The direction is same in a straight line. Also the magnitude is same. So this is a uniform velocity. Now non-uniform. If either the magnitude or direction or if both changes, it is non-uniform. Either of one changes, it is non-uniform. So first case is changing in direction. So take a ball, it is going like this, it is going upward and it is again coming down. So what is happening to ball's movement? Its direction is changing. It's going straight, it's coming up and again it's going down. Assume a bounce of a ball or something like that. So this is change in direction. Next is change in magnitude. What do you mean by magnitude? The distance covered here. So see, in the first time interval, it is covering so many distance. Next, it is reduced. Again, it is increased. So it is changing. The magnitude or the distance is changing constantly here. Now, if both magnitude and direction changes simultaneously. So see, first it is going for certain distance. Again, it is reduced and it is increasing. So this is about magnitude. Now also the direction is changing. It is going straight, it is going up, again it's coming down, again it's coming more down. So the direction is also changing along with the magnitude. So these are the three examples for non-uniform motion. Either it can change in direction or in magnitude or in both direction and magnitude. If any one changes, it is non-uniform velocity. Please note down. Now we learn about average velocity. Previously you learnt about average speed. What was the formula for average speed? Total distance by total time. Similarly, what is average velocity? So to find average speed you had only one formula, total distance by total time. But for average, to calculate average velocity, you will have to consider two different cases because this is a vector quantity. Now first, when the magnitude of velocity is varying, it changes but with in a uniform rate. So when the magnitude of velocity changes in uniform rate, what do you mean by uniform rate? Equal distance in equal time. When it is changing in uniform rate, your average velocity formula is initial velocity plus final velocity whole divided by 2. Initial means the rate at which the body is starting. Final velocity is the velocity of the body when it reaches its destination. So add initial and final velocity and divide it by 2. So this is your formula. So in a general mathematical form, we give it as VAV, which means average velocity is equals to, in physics your initial velocity is represented by u, small u, and final velocity is by v. So u plus v divided by 2. So clear? So this is when the magnitude is changing at uniform rate, correct? Now when the magnitude is not changing at uniform rate, what do you mean by not changing at uniform rate? It is varying, like our John problem which we did about John problem. For first few distance he is traveling at a higher speed, for the next few distance he is traveling at a lower speed, which means his speed is not uniform. So what happens when magnitude changing is non-uniform? Is not changing at uniform, yeah. So the average velocity will be just like your speed, total distance by total time. So clear? These are the two formula. When it is uniform, it is u plus v by 2. When it is non-uniform, it is total distance by total time. I hope you are clear. Now let me take an example. Two formulas. Please remember these two formulas and their conditions. Now read out the question very carefully. A object start with initial velocity of 4 meter per second. Assume you are moving. So you are moving with 4 meter per second and its velocity, assume its velocity is increasing by 2 meter per second. So a body is starting from 4 meter per second. So after it is increased by 2 meter per second. For how many seconds? For 3 seconds. So for every 3 seconds, the velocity is increasing by 2. So 4 and it is increases by 2 successively for 3 seconds. So after first second, so initially it was 4. Assume when you are starting it is 4. So after first second, what is happening? It should increase by 2, correct? So what is 4 plus 2? 6. Next. Now this will be my initial. Now after second second, it should again increase by 2. So 6 plus 2 is 8. Now after third second, it should again increase by 2 because it is successively increasing by 2. So 8 plus 2 is 10. So we got to know this is uniform. Why? Because it is increasing by 2 for every 3 seconds. So it is increasing by 2 means it is a uniform value. It is always increasing by 2. First 4, then 4 plus 2 is 6, 6 plus 2 is 8 and 8 plus 2 is 10. So we got to know this is a uniform change of velocity. What was the formula for uniform change of velocity? Initial plus final divided by 2, correct? Now what is my initial velocity? What is the body's initial velocity when it is starting? 4. It is starting at 4 meter per second. So u is 4. Now what is my final velocity which we found out by the question given? So it is 10. So 4 plus 10 divided by 2 according to my formula. So what is 4 plus 10? 14 by 2. So 14 by 2 is 7. What is the unit for velocity? Meter per second. So what is my average velocity? 7 meter per second. I hope you are clear.